So in this class, let us understand about straight lines. Now, a straight line is a very simple geometric figure, but it has got application in various fields. We talk about straight line in different aspects of life. If you want to construct a pillar, you say it should be along a straight line. All straight lines have two important characteristics. One is slope of the line, and second is intercept of the line. To represent the equation of a straight line algebraically, we require these two values of the straight line. One is slope and other is intercept. First, let us understand about the slope of the line, and then we will understand what is meant by intercept of the line. Okay. To understand the slope of the line, let's consider a coordinate system having the x-axis, the y-axis, and the origin. In the coordinate system, consider a straight line. Say A, C, B is a straight line. The line ACB, as you see here, makes two types of angles with the x-axis. This is the x-axis. It is making an angle XCA, and this angle is measured in anti-clockwise direction. And you have angle OCA, and this is measured in clockwise direction. So the line makes two types of angles with the x-axis which are supplementary. But for all practical purpose, we consider the angle made by the line with the x-axis in anti-clockwise direction. The angle XCA is also called as positive direction of x-axis. And for all practical purpose, whether to number the quadrants or to understand what is meant by slope of the line, we consider the positive direction of the x-axis, which always begins from right side to left side. The positive direction starts at x, and it is in the direction x to x dash, which is in fact, it's like this, x to x dash, which is the anti-clockwise direction or the positive direction of the x-axis. Let this angle be theta. It is angle XCA is equal to theta. Angle XCA is called inclination of the line. This angle has got a name, and that name is called inclination. You know what is meant by inclination of a line? If you draw any line in the coordinate system, you will always have two types of angles made by the line with the x-axis. For all practical purpose, you consider the angle made by the line with the x-axis in positive direction, that is in anti-clockwise direction. If theta is the angle, then angle theta is called as the inclination of the line. Now, if you introduce the trigonometric function tangent to theta, then it implies tan theta, or it becomes tan theta. This tan theta is called as slope of the line. This is called as slope of the line AB, and it is denoted by m. So we get a simple formula for the slope of the line. M is the symbolic representation of the slope of a line. Tan theta is the numerical value of the slope of the line. And the slope of the line can be defined as tangent of the angle made by the line with the x-axis in anti-clockwise direction. So remember, what is meant by slope of a straight line? If you want to talk about the slope, then you should have the trigonometric function tangent of inclination, because theta is called as inclination. Theta is the inclination of the line. If you introduce tangent to the inclination, then whatever the value you get is called slope. For example, if a line makes 60 degree with the x-axis in positive direction, then its slope is tan 60, and that is equal to root 3. So remember that the slope is a real finite number, and it is always obtained by considering the tangent of the angle made by the line with the x-axis in positive direction. Now let's understand the slope of a straight line under different situations. Supposing the line that we are talking about is parallel to x-axis. AB is parallel to x-axis. Then it does not make any inclination at all because the line is parallel. So there is no angle between the line and the x-axis, or what is same as saying that inclination is 0 because the line is parallel to the x-axis. Therefore, its slope m is tan 0, and that is equal to 0. So you get m is equal to 0. So point number 1 is that if m is equal to 0, that is slope of a line is 0, it means that the line is parallel to x-axis. So what is the important statement here? If the slope of a line is 0, then it is parallel to x-axis. Or if you take the converse of this statement, if a line is parallel to the x-axis, then its slope should be equal to 0. And take another instance. A line which is purely vertical, that is perpendicular to the x-axis now. You know that this angle is 90 degree, inclination is 90 degree, therefore slope, that is m, is tan 90, and tan 90 is infinity, and that is not defined. Therefore, the slope of a line which is perpendicular to the x-axis is not defined. Case number 3. Let us consider a system of lines which are parallel to one another. In the coordinate system, let's have some lines, say line 1, line 2, line 3, line 4, etc. and n number of lines. This is L1, L2, L3, etc. Ln. All these lines are parallel to one another. Therefore, the angles made by these lines with the x-axis in the anti-clockwise direction should be same. Supposing this is alpha, beta, gamma, etc. and theta, then it means that alpha equals, beta equals, gamma equals, etc. equals theta. Because all these lines are parallel to one another, therefore these angles must be same. Or if I introduce tangent to these angles, then tan alpha equals, tan beta equals, tan gamma equals, etc. tan theta. That is, if tan alpha represents the slope of first line m1 and m2 is the slope of second line, if m3 denotes the slope of third line and mn is the slope of fourth line, then it follows that m1 equals, m2 equals, m3 equals, etc. equals mn, or simply all these values put together to one common value m. So what is the meaning of this? It means that if lines are parallel to one another, then their slopes are equal. Or the converse, if many lines have the same slope in the coordinate system, then they are bound to be parallel. So point number 3 is to note that if lines are parallel, then their slopes are equal. Or I write two parallel lines have same slope or equal slope. Or if two lines have same slope, then they are bound to be parallel to one another. And this is called as the phenomenon of parallelism of lines. Okay, this is about point 3. Now I want to note about point 4. In the coordinate system, I have a line like this. ACB is the line and this is x-axis. Now if you look at angle XCB is very clearly, it is an acute angle because it is less than 90 degree. Now, therefore, the slope is tan of this acute angle. You know, the tan of any acute angle is positive. So it is positive. Or we say that slope is positive. Slope is positive means tan theta is positive, which means that theta is acute. So if any line makes an acute angle with x-axis in positive direction, then its slope is positive. This is point number 4. Point number 5. If the line makes an obtuse angle with the x-axis, look at this. The line is making an angle which is greater than 90. So here theta is greater than 90. Tan theta is greater than. Now what happens to the value of tan theta? Tan theta becomes negative because if theta is greater than 90, then tan theta is negative. Or what is same as saying that slope is negative. So if the slope of a straight line is negative, then it makes an obtuse angle with the x-axis in anti-clockwise direction. If the slope of a line is positive, then the line makes an acute angle with the x-axis in positive direction. If the slope of a line is 0, then the line is parallel to the x-axis itself. So slope can be 0 or positive or negative.